Hello, Algebra 1. I am at home taking care of my sick daughter, and so I'm making this video for you today to go through the lesson. The big thing to remember is that tomorrow is going to be your concept quiz. So this is the last lesson before that, so here we go. To start out this lesson, we're going to review exponent rules a little bit. So I want you to think back to what you know about what do you do with the exponents when you multiply with the same base. Try these on your own and then talk with a neighbor and then start the video again when you're ready. Okay, to talk through these a little bit, their first one, 2 to the 4th times 2 to the 0 power. Well, anything to the 0 power is 1, so it's the same as 2 to the 4th times 1, which is just 2 to the 4th. The next one, 2 to the 4th times 2 to the negative 1 power. This is the first time we're seeing that negative exponent, and if you simply add your exponents together, 4 plus negative 1 is 3, so it's the same as 2 to the 3rd. But here's a little bit more about how that works. 2 to the 4th times 2 to the negative 1. Well, 2 to the negative 1 is the same as 1 over 2 to the positive 1 power. So that negative exponent, I like to say that it kicks it to the denominator. And now we have 2 to the 4th times 1/2. And if we multiply that out a little bit more, there's 2 to the 4th times 1/2. Well, if I simplify before I multiply, I would be able to get rid of some of those 2's, and so I'm left with 2 to the 3rd, which is what we see using our exponent rules by adding over here. Here's a look at the last two. 2 to the 4th times 2 to the negative 3 power. That negative exponent kicks it to the denominator, so that's the same as 1 over 2 to the 3rd power. And here's another way to think about it rather than writing everything out. If I multiply at this point, I'm going to think about my 2 to the 4th over 1. I'm going to multiply across the top, that's 2 to the 4th. Multiply across the bottom, that's 2 to the 3rd. And we've already seen using exponent rules that when we're dividing, we can subtract the exponents. And so that would be the same as 2 to the 1st, which is what we saw over on the left by adding your exponents. Then the last one, 2 to the 4th times 2 to the negative 4th. Again, that negative exponent kicks it to the denominator. And so I have 1 over 2 to the 4th. And if I multiply that one out, I would have 2 to the 4th over 1. And so I have 2 to the 4th, multiply across the top, 2 to the 4th, multiply across the bottom, and that's going to be the same as just 1. The next activity, 7.2, is called Coral in the Sea. There's 4 questions with this. I want you to try it on your own for a few minutes first, and then start the video when you're ready. Okay, looking at number 1. Looking at your equation, this is going to be an exponential equation. So your starting value for A is 1,200. That's what we started with. And your growth factor is 2 because it's doubling each year. And then our exponent here is T, and that's going to represent years. Okay, using the equation that we wrote, we're going to find the volume of the coral when T is 5, 1, 0, -1, and -2. I created this table here to organize it. And all I did was I plugged in these values for T into the equation, and these were the values that we got out for the volume. And what does it mean in this situation when T is -2? Well, that means that that was the volume of the coral 2 years before the data was collected. So if you remember it this way, times 0, that was when they first went out and measured the coral. And then they measured it some more, and we're estimating that it was doubling each year. But we can kind of go back in time by using negative exponents. So -1 would be 1 year before that coral was measured. So if it was 1,200 when you measured it, and you think it doubled every year, well, the year before, then it must have been 600. And the year before that, it would have been 300. And there's your T for -2. And number 4, in a certain year, the volume of the coral is 37.5 cubic centimeters. What year is this? Well, if you use your equation, you can put in that 37.5 for the volume, and then you're playing around and trying to figure out what that exponent needs to be. There is a way to solve this type of equation. That's way down the road for you guys. So right now, it's a little bit of trial and error, or you could graph it and see when does the volume equal 37.5. So we do see that the negative exponent of -5 makes it work, which means that 5 years before the coral was measured, its volume would have been 37.5. We are going to skip to activity 4 here, measuring meds. And the premise behind this one is that someone took some medicine. They think they took too much, but they're not sure. That is a dangerous situation. So they went into the doctor and they're going to do a blood test every hour to see how much medicine they have in their bloodstream and see what they need to do. So go ahead and try these questions. There's 4 of them, I believe, and then start again when you're ready. So looking at this one, the equation that we wrote is going to be 100, that's your starting value according to the table here, times 1/2, that's the growth factor because every time or every hour, the amount that's in the bloodstream is getting cut in half to the T power. Excuse me. Find the amounts of medicine in the patient's body when T is -1 and -3. So I put them here at -1 hours, there would have been 200 milligrams in the bloodstream, and at -3 hours, there would have been 800 milligrams in the bloodstream. You can figure that out by plugging in -1 and -3 for T, or you can kind of use some reasoning and going backwards in the table, work through it that way. What do T equals 0 and T equals -3 mean in this context? Well, 0 would have been the first time the blood test was taken. So like that's when they got to the doctor. -3 would mean 3 hours before that blood test was taken. And number 3, when T is -5, how much medicine was there in her body? This would be how much she had taken. So if I plug in -5 to my equation, 1/2 to the -5 power would be 32. 100 times 32 would be 3,200 milligrams. So that's how much the patient took. And then creating your graph, it could look something like this down here. Maybe you use different scales, but we need to show the correct value. So at -3, there would be 800, at -2, 400, at -1, 200, so on and so forth. So as long as it matches those values from your table, you're good to go. And now going to your lesson summary real quick. This is in your lesson summary, and it's just a quick review of what that negative exponent does. So here 2 to the -5th is going to be the same as 1 over 2 to the 5th. Remember, it kicks it to the denominator. That ends up being 1/32, and that's why when we have negative exponents, we often end up with smaller answers because we're oftentimes multiplying by that fraction.